This is the first lesson on integration by parts. It's a method of integrating products where we've got two distinct functions of x. A bit like the integration version of the product rule for differentiation. Okay, so this is the formula we use. We split our product. Instead of uv like we did with the product rule for differentiation, we split the integral into u and dv dx. This enables us to integrate one of the factors and differentiate the other. And we end up with this formula here. This can be derived using the product rule for differentiation, which I'll actually put on the presentation for the lesson if people want to see it, but it's not actually required that you know this. So we're just going to learn how to use the formula. So we differentiate the u and we integrate the dv dx to get v. Notice that this part, this second term on the right hand side, still needs to be integrated. So integration by parts is only useful if we can make this easier to integrate. Okay, let's try some examples. So if we make u2x for this integral here, dv dx sine x, we differentiate the u and we integrate the dv dx. Don't worry about the plus c yet, we'll put that in when we get the result for the whole thing. It's just adding a constant, isn't it? So it doesn't matter when we do it. So plugging all that into the formula. That's what we get, and we can now see that we've got something we can integrate here. So we've ended up with an integral here that we can integrate. So using integration by parts, splitting our product into a u and a dv dx has enabled us to end up in a situation where we can now get rid of the integral. We can do the integration here. And that's what we get. Okay, another example. This time we'll make the ux and the dv dx e to the 2x. We need to be a little bit careful with this one. Remember, e to the x integrates to e to the x, but e to the 2x integrates to e to the 2x over 2. Plug everything in, and now again we can see here we've got something we can integrate. We can integrate this. And there we are. Have a little think about this one and the previous example at what might have happened if you'd made the second factor the u and the first factor the dv dx. Okay, here's some for you to try. This will do us for the first lesson, so if you're successful at these, then you're ready for the lesson. Pause the presentation, have a go. Right, let's look at the solutions. So there's the answer to the first one. Hopefully you've worked out by now the importance of making the x term the u and the e to the x or the trig term the dv dx. Otherwise you might have had problems. I did ask you before to have a little think about what might have happened if you'd done them the other way around. And again, that's what you should have got. So if you're successful with those, you're ready to move on. If not, go back over it, make sure you understand. It really is just following the process, very much like the product rule and the quotient rule. write out your u, write out your dvdx, differentiate the u, integrate the dvdx, stick everything in the formula. With definite integrals, it's exactly the same. Carry out the first part first, exactly as we've just done, and then put your limits in. And there we go. So there's an example there, so you can see that it's a straightforward process for definite integrals. Integration by parts doesn't always work. It only works if one of the factors can be integrated and the integral we end up with on the right hand side is easier than the one we started with. As we'll see next lesson, it is possible that we might have integrals on the right hand side that don't integrate and maybe require parts again and even again, but eventually we will be able to integrate them.